Good afternoon and welcome to ElectroBIM training. We are going to be looking at ground sizing today. Ground sizing is covered by NEC 250, which is a pretty big chapter. It's 25 pages, split into 9 parts. There's 191 sections to it. We're going to talk specifically about the parts of NEC 250 that we implement for you in ElectroBIM. The idea is that you as the engineer obviously need to understand how grounds work. We're going to automate some of the sizing for you. Specifically, there are 3 tables used for sizing grounds. There's NEC 250-66, 250-102, and 250-122. The first one is 250-66. That's for the grounding electrode conductor. We actually don't do the sizing on that. And we will come back to how you handle that at the end of this training. So we'll come back to 250-66. Otherwise, we have 250-122, which is for equipment grounds, and 250-102, which is for service grounds. And we do sizing for that. And these are the grounds that are going to be in your feeders or your branch circuits. The first place to look for the sizing and how we handle this is under customization in Wire Ampacities. This is where we list all of your ampacities with the corresponding wire size, and then also the corresponding ground size. And we have 2 columns here. We have the service ground and we have the equipment ground. The service ground corresponds to 250-102. The equipment ground corresponds to 250-122. The service ground, that's for separately derived systems. It goes back in the NEC to 250.30 is where that's referenced. The equipment ground is in part 6, which is equipment ground. That starts at 250-102. All of these NEC references are for the 2023 NEC. They keep changing the wording in this section, so it's keeps evolving. So this is all current as of the NEC 2023. So we have these 2 columns for sizing your grounds. We use the service ground column when you are connected to a transformer or to nothing. So if there's nothing feeding it and we're looking at the feeder for the thing that has nothing upstream of it, that's going to use the service ground. If you're being fed from a transformer, that's also going to use the service ground. Everything else by default is going to use the equipment ground. So that's how we choose between these 2 columns. If we go take a look at how that is implemented, if we go to panel edit, let's take a look at this MDP1. It's being fed from a switchboard that is not a transformer. So if we go down to the feeder sizing section under ground, it says size automatically. It's going to be using the equipment ground. If we take a look at PP1A, it is being fed from a transformer. So it's going to be using the service ground. That's not actually notated here. You just have to know what's upstream of it to know which ground we're choosing. You do have the option to override that. So you can say for a specific feeder, if you want to size it to the equipment ground or the service ground, and we'll choose those 2 columns for you. You always also have the option to set it to none or a specific ground size. So for whatever reason, a specific ground isn't right, you can, on a specific feeder basis, set that ground to what it needs to be. So that's how we're choosing the equipment versus service, is based upon what's upstream with the ability to override that. On your single line diagram, we have feeder IDs. We have different designations for the feeder IDs based upon the type of ground. If it's an equipment ground, we don't do any labeling. So like this panel here is being fed from this other panel. It's a 100 amp feeder. It's 100 amp is the ID. This panel is being fed from a transformer. It's a 100J. So that J is for the service supply side jumper is what that J reference is. And that's the actual label in the table in the NEC. That J is customizable. So if you go into project options and we go down to the feeder ID section, the service ground letter, we have 3 options. It used to always be J, but we added options for this. We added T for transformer, which is actually our new default. Any new projects are going to have T. And then we also added S for service ground, which is somewhat, it matches a little bit better what it is, but S and 5 are very similar. So I tried to keep away from the S. So that's why we added the J, and actually customers suggested T for transformer, which I believe is actually probably the best choice. But you have those options. And you always have the option to override our feeder IDs. If you want more information about that, go check out the feeder ID training because we got a bunch of training on that. But just realize that the feeder ID is going to be labeled differently based on whether it's an equipment ground or a service ground, and then how that service ground is labeled is based upon this option here. If we take a look at the feeder IDs, so we go to the project feeder ID schedule, you can see that the ground type is listed. So we have the 100, and then we have essentially two 100s, one with an equipment ground, one with the service ground. They have different ground sizes. They're going to have different IDs. You do end up in cases where you can have the same ground, and so you'll actually have the same call out, but we will give them different IDs because the ground, even though the ground is sized the same, it's being sized from a different table. So we still differentiate that. So if we go take a look at wire ampacities for 150 amps, that's where the two ground sizes are actually the same. So it's a number 6 service ground, also a number 6 equipment ground. Those will get different IDs, even though they are exactly the same feeder call out. For the sizing of the ground, it is all set in this table. So you can override this with whatever you want your equipment ground sizes to be. These are all based upon the NEC. So generally you're not going to be changing them, but you can change it from what we have. There's two questions that really come up with where our numbers come from. The first is, what do you do about parallel runs? So equipment grounds, that's NEC 250-122, those are based upon the overcurrent protection size. So that's based upon your breaker. So that ignores the parallel runs. So you can see that the equipment grounds, as you go down this list, just increase in size. They're being based upon this breaker size, totally ignoring the parallel runs. That's fairly straightforward. There's no question as to how the equipment ground should be done. The service grounds, there is a little bit of debate as to how you should size the service ground, as to whether it should take into account the parallel runs, because the service ground is based upon the conductor size, not the breaker size. And so then the question there is, if you have two parallel runs, are you sizing based upon the single parallel run that's in that conduit that the ground is in, or are you basing the ground size upon the combined area of all of those parallel runs? We size it based upon the individual run, not the combined area. So our ground sizes are not just increasing, they actually drop back down based upon the number of parallel runs. You can see that by looking at this 500 amp and this 250 amp row. This 500 amp is two parallel runs. It's essentially two runs of 250 amp wire. And the equipment ground has gone from number 4 to number 2 because we're basing it based upon the breaker size, but the service ground is still a number 2. It did not increase in size because we're basing it on the conductor size, the single run of conductors, not the combined 500 kc mil comparable size. If you want to size based upon the total area, including the parallel runs, you could just come in here and change these sizes yourself. So you have the option to override what we've done. Most people generally agree that this is the way it's been done, but we do have questions on that, and that is how you could change that. The other question we get on the default ground sizing is copper versus aluminum. All of our ground sizes are copper wires. Out of the box, we provide a copper and an aluminum option for each wire size. So the conductor sizes change from copper to aluminum. The grounds are still copper in our system. And again, this is where people disagree as to whether those grounds should be copper or they should be aluminum. Our best guess is that copper is the more common choice for the ground size, but there's certainly lots of people who do aluminum ground sizes as well. If that is you, you will need to manually come in here and adjust these sizes in your wire ampacities from the appropriate copper size to the appropriate aluminum size, and then use that customization in future projects. So for the most part, the sizing of the ground is pretty straightforward based upon the ampacity of the breaker or the wire. However, for equipment grounds, there is one more wrinkle, which is 250-122B, which says that if you increase the conductor size, you have to increase the ground size proportionally. If you go into wire sizes, this is why we actually have two areas for our wire sizes. We have the wire plus the insulation area. That is what we use for conduit fill. And then we have the wire only area, which is what we use for this proportional upsize, because we need to know how much bigger the wire is getting so that then we can upsize the ground proportionally. It doesn't matter a whole lot, but there are a couple edge cases where this does come into play. So we have this second column, which is the area of just the wire. And you can see here, we've got aluminum wire with one set of wire plus insulation areas and then one set of wire only. If I switch that to copper, this middle column changes, but that other column does not, because the wire only area is the same, because that's the size of the wire. It's the insulation that's changing based upon the setting of these two wire types. So when you increase your conductor size, you need to increase your ground size. Now, ElectroBIM is going to have to do a little bit of guessing as to what you're intending with your settings as to whether this comes into play. In general, if you change your conductor size over your breaker size, we're going to assume that this comes into play and we're going to upsize the ground proportionally for you. If that's not the case, if we upsize it, so we generally tend toward upsizing pretty generously. We tend to favor upsizing rather than not. If you have a case where we are upsizing the ground and it shouldn't be, that's where you can come back and manually override that ground size. Looking at these two panels, PP1B and PP2B, they're a 300 and a 250 amp panel. We'll go take a look at those in our panel edit. So for a 300 amp feeder, we have a number 4 ground. For a 250 amp feeder, we also have a number 4 ground. But if we upsize this for voltage drop, so we go from 250 amps to 300 amps, that is going to upsize the ground to a number 2 ground. So if we look at PP1B as 350 kcmil wire, number 4 ground, PP2B 350 kcmil wire again, but a number 2 ground. We upsize that feeder, and so we are upsizing the ground proportionally. Then when we look at the feeder IDs on the single line diagram, you'll see that we have different IDs for these two feeders. We have 300 and then this 300.A. We have that .A saying that this is another 300 amp feeder, but it's a little bit different than our other ones. And so we do .ABC as the nomenclature we've come up with for these additional sizes. You can come up with your own if you don't like those and override our IDs. So if we take a look at the feeder schedule, you can see that the 300 has that number 4 ground, the 300.A has the number 2 ground. So we're documenting that on the single line diagram for you. This does have interesting implications for branch circuits. If we run our circuit edit command and go take a look at a branch circuit, for your small branch circuits, they're generally number 12 wires and a number 12 ground. You don't usually upsize them all that much, but the way it's written is that if you upsize this to something large, if we take this up to 100 amp wire, if you needed that for whatever purpose, you're going to get a number 1 conduit and also a number 1 ground, because it's going to upsize proportionally. They were the same size, so they're going to continue to be the same size. So whatever size wire you choose, you're going to end up with the same size ground. So that comes up a little bit when people are upsizing their branch circuits. Just the way that NEC is written is that when you have a small breaker and you need to have a large wire, you also need to have a correspondingly large ground with it. One more place this comes into play is when we are looking at devices in your project. I'm going to take this cooling tower, and if we run our instance edit, we have the ability to size the breaker and the wire based upon MCA and MOCP. So if we set our MCA at 40, our MOCP at 100, and then size based upon those, we're now going to have a 40 amp wire and a 100 amp breaker. We take a look at that in circuit edit. We have the number 8 wire, but the ground is going to be based upon the breaker size. So it's a 100 amp breaker, it's a 40 amp wire. So we get the ground that corresponds to the 100 amp breaker. And then if we upsize this, again, if we upsize the conductors, we need to upsize the ground as well. So if we change this wire size here, you're going to get a new ground size. So if we upsize this to 100 amp conductor, again, you're going to get that number 1 ground. If you didn't want it to upsize for whatever reason, that's where you can come in here in the ground size and put it back to number 8, if that's what you actually wanted to have. So this is all for when we're sizing the ground automatically. If that automatic sizing is upsizing more than you want, you can always go into the ground and change it to what it should be specifically. That is what we do for sizing grounds. That's the equipment and service ground, NEC 250.122 and 250.102. There is also NEC 250.66. It used to be that 250.102 referred back to 250.66 for the sizing. Somewhere around 2010, they split those out. So it's been 15 years now, but they actually split those two tables out. They're the same table, but they have the tables in the two separate places to make it a little more clear. So that's, again, they've been slowly massaging this ground section to make it more clear. But 25066 is for the grounding electrode conductor, which is the ground on your utility transformer, essentially. We don't do any sizing for this conductor. We're sizing the wire in the feeder, but that's not exactly the same as the grounding electrode conductor. So for this, you have to manually probably draw in the ground, manually put in a label for the size, and manually set that wire size. We don't have anything that will size it for you automatically. You also typically then don't have a ground wire running back to your utility transformer. So in that case, you need to manually remove that ground. So the switchboard is being fed from this service transformer. If we don't want that ground, you come in here and you change that ground from size automatically to none. Now we have no ground wire. Our ID, the default out of the box, is going to put a U on for ungrounded. So we now have a 600 amp ungrounded wire going back to this utility transformer. And the GEC, you would need to insert and label manually separate from ElectroBIM.